I'm going to do a type conversion here. So let's quickly talk about type conversion before moving on to the example. So type conversion is basically when you convert a type of a variable to another data type. So we have all these functions here which will convert the data type into their respective counterparts. Now let's try to look at the example now. So we are getting an error here. But what if I change the data type of integer into string? Am I going to get the same error again or not? Let's just see. We're not going to get any errors. So this is what is all about type conversion. Let me show you one more example. So we had a dictionary over there that is with the name B. What I'm going to do is I'm going to use the list function and specify B over there. So I have actually converted our dictionary into a list. So this is what is type conversion all about. Collections in Python. Before moving on, let's take a look at the agenda for this session. So first of all, I will be talking about what are collections in Python, and then I will discuss what is the collections module in Python and how we can use it. And finally, I will sum up this session with various specialized data structures that are present in the collections module. I hope you guys are clear with the agenda. Also, I suggest you to subscribe to Edureka channel for more exciting tutorials, and also press the bell icon to get the latest updates from Edureka. Now, without wasting any more time, let's understand what are collections in Python. Collections in Python are basically container data types, namely list, sets, tuples, and dictionary. They have different characteristics based on the declaration type and the usage as well. So let's take a look at each of them. So talking about list, a list is declared in square brackets, guys. It is mutable, which means you can actually change the values once you have declared a list. And it also stores duplicate values, and the elements can be accessed using the indexes. Now talking about tuple, a tuple is ordered and immutable in nature, which means you cannot change a value inside a tuple once you have declared it. And a tuple can also have duplicate entries present inside it. Now talking about a set is unordered and declared in curly brackets. It is not indexed, which means you cannot access the elements inside a set using the indexes. Also, it does not have any duplicate entries present as well. Now talking about a dictionary has key value pairs and is mutable in nature, which means we can change the values inside a dictionary, and we use the curly brackets to declare a dictionary as well. So these are the Python's general purpose built-in container data types. But as we all know, Python always has a little something extra to offer. So it comes with a Python module named collections, which has specialized data structures. So let's take a look at the Python collections module, guys. What is it and how we can use it? So Python programming language has 4 collection data types that I have already told you, which is list, tuple, sets, and dictionary. But Python also comes with a built-in module known as collections, which has specialized data structures, which basically covers for the shortcomings of the 4 data types. Now, collections module in Python implements specialized data structures which provide alternative to Python's built-in container data types. So let's take a look at those specialized data structures in collections module. Also, you don't have to install collections like other Python modules, guys. It is already there inside Python. You can just import it by writing this name collections. So I'll show you while we are working on the use case, guys. So taking a look at the specialized collection data types, guys. So first of all, we have a name tuple. Then we have chain map, deck. There is counter, order dictionary, default dictionary. Then we have user dictionary, user list, and user string. So we'll be taking a look at each of them one by one, guys. So let's take a look at name tuple, guys. So what exactly is name tuple? Name tuple returns a tuple with a named entry, which means there will be the name assigned to each value inside a tuple. Now, if you look at the tuple as in general, it does not have any named entries, but with name tuple, we can do that. So it actually overcomes the problem of accessing the elements using the index values. With name tuple, it becomes easier to access these values since you do not have to remember the index values to get the specific elements. Now, here is an example, guys. So this is what a name tuple looks like, guys. So let me take up to PyCharm, guys. We'll try to implement a name tuple using the collections module. So we are inside the PyCharm, guys. I hope this is visible to you. So first of all, what we'll do is we'll import the collection module, and from collections, okay, as you can see, I have not installed it or anything. You can just write collections and it will appear there. So from collections, I want to import name tuple, guys. Done. Now what I'll do is I'll simply, okay, let me implement a name tuple first. So I'll just make it as A and use name tuple here. And over here, I will just provide some values. Let's say the name of my name tuple will be courses. I have to put it in commas guys. Now I have to give some names, like I'll just write course name and then let's say technology. Now what I'll do is I'll make one more variable and I will pass this and provide some values over here. For my course name, I'll write data science, and for technology, let's say Python. Now when I print S over here, let's see what happens. So as you can see, I'm getting the output as this courses, which is the name of my tuple. And over here, I'm getting the named entries for these values that I've put inside this tuple, guys. So this is how you can implement a name tuple, guys. It's as easy as it looks. You just have to import it from collections, and after that you have to implement a name tuple, and inside that I have provided the name and the values that are going to be there for the tuple, guys. Now I'll show you one more thing, guys, how you can actually get the value or implement a tuple using a list, guys. So let's take a look at that. So what I'll do is I'll take one more variable, let's say S. Now what I'll do is I'll just specify using this variable over here, and I will use make, and over here I can just make a list and I will provide values like, let's say artificial intelligence, and technology is going to be Python, guys. So if you're wondering why am I making these courses are available at our Edureka website, guys. You can check them out anytime you want. So now when I print this, let's see what is going to happen. So I've actually used a list to get a name tuple, guys, to get the values inside a name tuple. So this is all about name tuple, guys. It's actually pretty easy, and you can get named entries for your values inside the tuple. So let's take a look at the next one that we have, which is actually deck, guys. It is written as DQ, but we can pronounce it as deck. Now talking about deck, what actually it is used for. So deck, pronounced as deck, is an optimized list to perform insertion and deletion easily. So when I say optimized, what it actually means is there is a way where you can actually do it very precisely and very easily, guys. So let's take it up to PyCharm again, and we'll try to implement this. So from collections, instead of name tuple, what I'm going to do is I am going to import deck, guys. Now what I do is, so let me just specify a list over here. So I'll just write a few values here. Let's say Edureka, guys. Okay, let's see what's happening here. So now what I'm going to do is I'm going to use a variable, and inside this I will pass this list. Let's see what we get if I print this variable, guys. So I'm getting a DQ. I have made a deck using the list, guys. So let me show you the operations that we can perform in this. So first of all, let me append a value or add a value, guys. So what I'll do is I'll just append a value. So let's say append, and let's say Python. Yeah. So now when I print this, you will see the different, guys. So we have a deck over here, and after that I have appended a value or inserted a value using this append function, guys. So which means I have added the value at the end of the deck. Now if I want to add it like before the deck, guys, like in the beginning of the deck, what I have to do is I'll just have to use this method, which is append left. So now you'll see what is going to happen, guys. So this value Python is actually inserted in the beginning of the deck. Similarly, for removing a value, what I can do is, okay, I'll just, now we have added this value. Let's say I want to actually remove this value. So what I'll do is I'll just write d dot pop, and let's see what happens. I'll print it again. So as you can see, from the value from the end of the deck is missing now. We have actually removed it from the deck using the pop function. But let's see if I want to actually remove this value. How am I going to do it? I'll just write pop left, guys. And as you can see, the value Python is also missing here. So this is an optimized version of insertion and deletion, guys, using the deck. So this is all about deck, guys. Now let's talk about the next one that we have, which is a specialized data structure, obviously, and that is chain map. So chain map is a dictionary like class which is able to make single view of multiple mappings. So it basically returns a list of several other dictionaries. Suppose you have two dictionaries. Suppose you have two dictionaries with several key value pairs. So in this case, chain map will make a single list of both the dictionaries in it. So as you can see in this example, we have two dictionaries, A and B. And if I use the chain map, it will return me a single view of these two values. or multiple mappings. So let's take it up to PyCharm, guys. We'll try to implement this again. So I'll remove this, and instead of deck, we are going to use, or we are going to import chain map, guys. So it's very simple. So let me declare two dictionaries, guys. So first of all, I'll give a value, let's say one at Eureka. Then the second key value pair is going to be, let's say, Python. Now let's take one more, and inside this I'll give the value, let's say ML, and the fourth one is going to be, let's say, AI. Now using the chain map, I'm going to specify these two dictionaries in this. So let's print A1. Let's see what happens. So as you can see, I have made a chain map which has a single view for multiple mappings, which is A and B, guys. So this is what you can do using the chain map, guys. I hope you understand this. So this is a very basic example, guys, to let you actually understand what is happening over here. So we are using these two dictionaries, and we are able to get it inside a single view, guys. So let's take a look at the next one that we have, which is counter, guys. So counter is also like a dictionary subclass which is used to count hashable objects. Now, what are hashable objects? So let's take a look at this example. So let's say we have a list. Inside this we have different elements. So what counter is going to do is, okay, let's take it to PyCharm to understand this better, guys. So I'll remove this, and instead of chain map, let's say I have counter. So let's take a list, guys. So I'll specify some duplicate values because this is what it is used for, to count the hashable objects, guys. Now what I'll do is I'll make one variable and use the counter and pass A over here. So when I print C now, let's see what happens. So as you can see, I'm getting a dictionary inside which I have these values. So which is saying the number of times 2 has occurred is 5, number of times 4 has occurred is 3, and then again 1, 2 and all. So when I run this again, I'm getting the same value. So this is how you can actually use counter, guys, to count the hashable objects inside any iterable value. So we have a list, we can do it for any other iterable object, guys, like a tuple or set. So this is all about counter. I hope you understand this. Now in addition to the operation you can perform on a dictionary, counter has 3 more operations that we can perform. So which are basically an element function, a most common function, and a subtract function as well. So we'll talk about them in detail now. So talking about the element function, guys, so let's see what elements does. So we'll see elements now. So over here we want the list, so we will put it in the list constructor, guys, and let's print this. Okay, let's see what are we going to get. So it returns a list containing all the elements in the counter, guys. So as you can see, I'm getting all the values that I have inside the counter, and this is the counter that I have. So 2 comes 5 times, 1 comes 2 times, and then we have 3 2 times, 4 3 times, and so on. So this is the function of elements function, which is returning a list containing all the elements inside the counter. Now let's take a look at the next function that we have, which is the most common function. So let's get on to it. So we'll use the C, which is our counter, guys. So I'm going to use the most common here now. So let's see what I will get here. So I'm actually getting a sorted list with the count of each element inside the counter. So we have 2 5 times, 4 3 times, and 1 2 times, 3 2 times, 5 2 times, and 6 1 time. So this is actually how you can use the most common function. And then we have one more function, which is subtract, guys. So for subtract, let me get one more variable. So I want to subtract, let's say, so I'm getting 2 5 times, so I'll just subtract 2 1 time, and I'll subtract 6 1 time. So what I'll do now here is I'll use the counter and let me use the subtract function, guys. Here it is, and I will pass sub over here. Let's see what happens. Okay, so now when I print my counter, okay, I'll get the values, the most common values again. So now as you can see, 2 is coming 4 times here and 6 is coming 0 times because I have subtracted using the subtract function. So this was all about counter, guys. Let's talk about the next data structure, which is ordered dictionary. So ordered dictionary is a dictionary subclass which remembers the order in which the entries were added. Basically, even if you change the value of the key, the position will not be changed because of the order in which it was inserted in the dictionary. So let's take it up to PyCharm, guys. We'll implement the ordered dictionary over there. So I'll remove all this, and instead of counter, we will import ordered dictionary. Now what I'll do is I will implement an ordered dictionary, let's say D, and now I'll add a few values. Let's say, okay, the first one is going to be E, and then the second one is, let's say, D. Now let me print D over here, which is our ordered dictionary. Let's see what the output will be. So we have an ordered dictionary which is saying on the first value we have E, and then so on we have Edureka, all the letters from Edureka, guys. So this is how you can actually implement an ordered dictionary, guys. So let me take a look at what all functions do I have in this. So I have pop, update, pop item, get items, from keys, set default, values, clear, copy, keys. So let me get all the keys from this. So when I run this, okay, let me print this. Now as you can see, I'm getting the ordered dictionary keys, which is 1, 2, 3, 4, 5, and 7. And similarly, I can get, instead of keys, let's see what all we can get. We can update pop item. Okay, let's get items. So the functions are actually similar to what we have for dictionary, guys. So this is all about ordered dictionary, guys. It remembers the order in which the elements were put inside the dictionary, guys. Okay, let me do one thing, guys. I'll change the value. Okay, first let's print this so you'll understand it better. So now what I'll do is I will change the value at 1. So instead of E, let's say I want P over there. And now when I print it, let's say what happens. So as you can see, I have replaced the value over there. But since it was inserted in the beginning, like the first one was E, the value is not changing over there. So this is the main reason why we use ordered dictionary, because it remembers the order in which the elements are being added inside the dictionary. So now that we are done with ordered dictionary, let's talk about default dictionary, guys. So what basically default dictionary does is it is a dictionary subclass which calls a factory function to supply missing values. So in general, it does not throw any errors when a missing key value is called in a dictionary. So you'll understand this better, guys. So let's take a look at this example. We have a default dictionary in which we have to specify our type as well. So let's say we have two values. On the first value we have Edureka and then we have Python. But instead we want to print Java over there, which is not actually inside the dictionary because there is no value present over there. But we will not get any key value errors, and it will instead give the output as 0. So let's take it up to PyCharm, guys. We'll try to understand over there. So let's remove all this. Now instead of ordered dictionary, we are going to import default dictionary, guys. So let's make a default dictionary. And inside this, let's specify the type as well. Now let's say we have the first value as Python. The second value, let's say Edureka. Now when I print this D over here, I'm getting the value as it's showing me that we have a default dictionary which has a class int that we have specified over here. And then we have a dictionary with the values 1, 2, which has Python and Edureka respectively. Now let's say I want to get the value at the number 3, which is not actually present there. But I'm getting the output as 0. So I'll show you the difference, guys. What actually happens if you do this in a normal ordinary dictionary, guys. So I'll make one more dictionary, let's say A, and I'll give it some value, let's say Python and Edureka. Now when I print this, which is not actually present inside the dictionary, let's see what we are going to get. We are going to get the key error, guys, because 3 is not actually present inside this ordinary dictionary. But if you put it inside a default dictionary, you're not going to get this error, guys. So this is what is the function of default dictionary, guys. It does not show you or throw you any key error even if the value is missing inside the dictionary, guys. So now that we are done with default dictionary, let's take a look at the next one that we have. which is user dictionary, user list, and user string. So these three data structures are actually same but different. So let's talk about them one by one. So talking about user dictionary, this class acts as a wrapper around dictionary objects. Now the need for this class came from the necessity to subclass directly from the dictionary. It becomes easier to work with this class as the underlying dictionary becomes an attribute. Now talking about the user list, this class acts like a wrapper around the list objects, and it is useful base class for other list like classes which can inherit from them and override the existing methods or even add a few new ones as well. And the need for this class came from the necessity to subclass directly from list. It becomes easier to work with this class as the underlying list becomes an attribute as well. Now talking about user string, guys, it is also a wrapper around string objects for easier string subclassing. Now the need for this class has been partially supplanted by the ability to subclass directly from string. However, this class can be easier to work with because the underlying string is accessible as an attribute.